Hello everybody. I want to talk a little bit about the assessment of body composition. This is chapter 8. I'm just going to highlight some of the content, so make sure that you please pre-read that. Our goals are to talk about body composition and health, look at patterns of body fat distribution, and then look at assessment of body composition, and then we're going to talk a little bit about calculating target body weight. As well, we want to understand the importance of appropriate body composition, understand the various means of assessing body composition, and then we want to become proficient at estimating body fat through skin folds and girth measurements. This portion is the lab portion. You'll do simulated body composition skin folds, and then if you're an exercise science major in 340 lab, you'll have an opportunity to take some skin fold measurements, and then you'll actually do girth measurements, which are waist and hip measurements for the lab. So when we talk about body composition, what exactly are we talking about? Sometimes people just equate it to body fat, but we know that we can divide the body into different components. We have muscle, essential fat, non-essential fat, bone, and then other as a category. And we have differences in males and females. Regardless of what a female's decision is in life, she's designed to bear children. So there's going to be more fat deposit in the hip area, and then there's also breast tissue to consider. So in general, females will have a higher essential body fat than males. Essential doesn't equate to healthy. It just means that you have to have this amount in order to continue with bodily functions. So what exactly does fat do then if we talk about essential? Well, it protects organs. It helps with thermoregulation. Certain hormones are stored in fat. We have intramuscular fat stores that we use to fuel aerobic exercise, especially over the long term. Fat is a great way to store energy, and so we need to have fat to be considered healthy. When we use it in the lab, I'm going to keep moving myself around so I don't get in the way. When we are looking at it in lab, depending on our purposes, we measure athletes. Sometimes we measure people for general health guidelines. What we try to do is track changes over time. So if there's athletes come in preseason, and then we want to look at the end of their first training cycle to see if there's any differences. In this case, we have a female that's 20 years old. Her component body weight is here, and then we have her percent body fat, and then weight at body fat. The challenge with this post test, if you look, is she came in at 149.6, and then after the first training cycle, she was at 131.6. Her first body fat percentage was 16.3. Post testing was 8.1. This is below essential. So this was a case where the sports medicine team, along with the coaches, had to evaluate and talk with this student athlete because some negative behaviors were being established. So this is actually, this was several years ago, but this is actually a case where through the performance testing that I did, it went from performance testing to health. If the body fat percentage is too low for females, a couple of things can happen. One, you can go from having a predictable menstrual cycle to being amenorrhea, which means there's an absence of a menstrual cycle. If there's an absence of a menstrual cycle, then that female will begin to displace calcium in their bone matrix. And for ladies, age 22 is about when you establish that bone matrix that you're going to have for the rest of your life. So if she were to continue on this negative track where her percent body fat is too low, she's displacing calcium, that's going to lead to some health problems later in life. Okay, so we did do an intervention, and the intervention was successful, and the students' numbers did improve. So the way that we use it in the lab is to track changes over time. We don't do it to label somebody. We do it as a way to receive information. If someone's doing training and they're putting on lean mass, Well, all of a sudden you have female athletes that's going, man, I'm 8 pounds heavier than when I was at the beginning of the school. That 8 pounds could be a 10-pound gain in lean muscle mass and a 2-pound loss in fat mass. So whenever we determine body fat percentage, it's a lot better than just stepping on a scale, especially if we can determine if it's body fat or if it's lean mass. And we can do that through hydrostatic weighing. That's one of the assessment methods that's preferred. Here's another example. That's a specific example. I mean, I'm drawing these from data that I've actually collected over the years. And this is a student athlete's weight over time from 07, August 24th of 07, all the way for 3 years. We tracked this student athlete's weight through January 10th, and you can see she came in at 145.1. And this is common that her weight went down. She's training much harder than she did in high school, and then all of a sudden, it increases. You can see the body fat percentage decrease, and then there was one bump in body fat here, and then although there was a little change in weight, you can see a decrease in body comp. This means that she was laying down some lean mass, so her body really started to respond to training. So one reason we do body composition is to assess how well a person is responding. And with the College of Charleston, the size of our program, that's where we coordinate with athletics so that our students are getting exposed to some of this testing, and then they can get the results. Never ever do we just test a group of athletes and give it over to the coach. The first thing is, hey, how are you going to use these numbers? Are you going to label or are you going to use them in coordination with sports medicine to track progress? Because if there are a group of, say, 20 females on a sports team and you know that they're going to go through body comp testing, there can be a 10% chance that some are going to go into negative eating disorders. So you have to educate and you have to communicate how those results are going to be used, because it can very easily become a negative thing. So you want to make sure that you are treating body composition in a way that you're not alienating or increasing anxiety with athletes, both females and males. So we have recommended age-based body fat percentages. This is one area that a lot of organizations, there's different numbers for different organizations, but in general, for 18 to 34-year-old men, we're looking at a recommended 8 to 22% body fat range. Where females, we have 18 to 34, we're looking at 20 to 35%. Typically, you'll see 20 to 30% is considered the recommended range. And then as we get older, those numbers do change a little bit. Whenever you get older, you tend to lose lean mass. So this doesn't necessarily mean, hey, it's okay to gain body fat as you age. What it means is there's going to be a natural decline in percent lean mass. So then if there's no change in weight but lean mass goes down, that's a natural increase in percent body fat. That's why these numbers are a little bit different. You can look at obesity, and there's different classifications for obesity based on percent body fat or BMI. BMI and body fat are not the same thing. For obesity, if you have a percent body fat, we know that body fat's above 25%. Men are considered obese, and above 38% is obesity for females. And then males or females, if it's greater than or equal to 30 kilogram meters squared for BMI, then that's considered obese. We know that there's a prevalence of obesity in the United States. These numbers are from 2022, so they're more current than the ones in your book. And you can see that in the southern and midwestern states that the incidence of obesity is quite high. It's estimated to be 41.9% for adults 20 years of age or older, and 19.7% for 2 to 19-year-olds, which is quite scary. So here's some further categories. You can be underweight, which is oftentimes just as unhealthy as being overweight. So if a BMI is 18.5 or below, and here's the range for healthy, overweight and obese. Here's how we calculate BMI. BMI is based on height and it's based on body mass. We want to convert those to kilograms and centimeters because then we're going to take centimeters and convert it to meters. So in this case, 145 pounds, we know that there's 1 kilogram for every 2.2 pounds. So pounds cancel out. We divide 145 by 2.2 and get 65.9. For centimeters, to go from inches to centimeters, the conversion factor is 2.54. So 63.5 times 2.54 divided by 1 inch for every centimeter, we get 161.3 centimeters. To change that to meters, we simply move the decimal place 2 to get 1.61. So if you have a subject that's 145 pounds and they're 63.5 inches, their BMI is going to be 65.9 divided by a meter squared, which is 1.6 meters squared. So 65.9 kilograms divided by 2.6 meters squared, which is 25.3. This person would be in the overweight category by since they're 25.3. I chose this example from a specific athlete, letting you see that this athlete, let me move up here. This athlete's actual percent body fat, because I measured it. So remember, BMI isn't the same thing as body fat, but just looking at their BMI, they're considered overweight. Well, that's because they're an athlete. And even if you're a student that works out and you're not on a sports team, if you do resistance training, then a lot of times you can calculate BMI and you'll be overweight, but you're not overweight. You just have more lean mass than the people did when the original BMI formula was formulated. This case, this person, if I would have said, hey, yeah, man, they're overweight, their BMI is 25.3, their actual percent body fat is 14.9%. So I did hydrostatic weighing on this person. So they're in the athletic category between 14 and 20%. They're actually really lean, but yet their BMI says they're overweight. I guarantee, especially if you're a female and you do resistance training or you do any type of speed work or you do any HIIT training or you swim, you're going to have enough lean mass that's going to kick you into the overweight category when you're really not. Your body fat could be kind of low. That's one reason why we do skin folds and why we do hydrostatic weighing, because they're much better than just simply measuring someone's height and weight. And why use BMI? It works if someone's prepubescent or they don't do a lot of resistance training. Then it's a much better measure than if they're simply lifting weights or doing any type of speed work, because that person's going to have some lean mass. Here's another example where the subject was 153.9 pounds, and so we have 70.0 kilograms. Their height was 63.1, which is 1.6 meters. So their BMI was 27.2. What's really ironic is their percent body fat was 27.3. So in some cases, the numbers are really close, but they're not the same thing. BMI is a relationship between height and weight, and percent body fat is a relationship between the amount of fat one has compared to their total body mass. So it's important to know those two distinctions. Other methods, in lab, you'll do girth measurements, you'll do simulated skin fold measurements, and 340 lab exercise physiology, which is 340 lab, you'll do hydrostatic weighing. Air displacement, we don't do at the College of Charleston, and we do have a DEXA machine, so you might get exposed to that in ex-phys. Whenever you're doing your Girth measurements, these definitions are in your book and also in the ACSM guide. We know that the waist is the narrowest point of the torso between the xiphoid process. The xiphoid process you can palpate. It's right in here. It's right in here. And then the umbilicus is your belly button. So the waist is the narrowest point between xiphoid process and your belly button. Okay. And then the hips, it's the widest place south of the umbilicus. Okay. And the gluteal fold is where your gluteus maximus, where the bottom fold of your buttocks is. All right, so these are common measurements. When you measure these, you measure them from the side. How are you going to do that for lab? Well, you can take a string and then measure it with a string and then take that measure and measure it with a ruler, or if you have a tape measure. You don't have to put like a metal tape measure around your waist. I would use a string or even a belt and then transpose that measurement from the belt using a steel ruler. Okay, so it's not that hard to do. This is what we use in lab, and this metal part has a spring tension because when you're measuring, you don't want to dig in. So if you need to review, the protocol is in your ACSM book, but you also can refer to this slide. And then once you measure waist and once you measure hips, it's quite easy. You just divide the waist measurement by the hip measurement. In this case, the person's 0.82. We know that a waist to hip ratio greater than 0.95 for men or 0.86 for young women is associated with greater health risks. In part 2, I'll walk you through the skin fold theory and technique, and then we'll finish up the objectives for this chapter. So stay tuned.